Hello everyone, welcome to the next module, which is Introduction to Python Visualization. So in this particular module, we are going to be looking at three different topics, which is all related to Python data visualization, which is introduction, plots, graphs, and categorical plotting. So in the first part, we will be going through all the slides, and in the second part, I'm also going to take you through a few codes. So let's quickly look at our first topic, which is Python libraries for data visualization. Before we even start off with all of these different libraries, let's understand what is data visualization. So data visualization is basically the representation of data in a graphical or a pictorial format. So the primary goal of data visualization is to basically present a very complex data set or data in a understandable as well as in an accessible way, making it easier for people to grasp patterns, trends, and even insights. So data is often presented, via charts, via graphs, via maps, or other visual elements so that it can help the user quickly interpret information. So there are many modern data visualizations that are very interactive. It allows you and me as users to explore as well as manipulate the data to gain deeper insights. It has a very interactive, the interactivity can actually include, you can actually zoom these, data visualization, you can filter them, and you can also even tooltip them. Using effective data visualization, you can gain very clear and concise, results, and you can even avoid any unnecessary complexities. So they should be the data visualizations that you have created, they should basically communicate information that is efficient as well as very easy to understand to the broad audience with technical or without technical background. Also, data visualizations are often used to, tell you a story or convey a specific message. By combining data with any narrative elements, they help you guide your viewers through a very logical flow of information. There are various different types of visualizations. Okay, there are employed depending on the nature of the data as well as insights. So the common types of visualizations that you will come across is charts, line graph, pie graph, scatter plots, heat maps, etc. Now, thinking about data visualization, what are the numerous tools that are available in the market? So there are a number of tools as well as software applications designed specifically for creating data visualization, such as Tableau, Microsoft Power BI, as well as Python libraries like Seaborn, Matplotlib, etc. So you can, to summarize data visualization, it is widely used across different domains, okay, including healthcare, finance, business, and science and journalism, and a number of industries, so that you can help the stakeholders to make very informed decisions and gain a better understanding of complex data set. Now, let's discuss the different Python libraries for data visualization. So the first Python library is Matplotlib. So Matplotlib is one of the foundational libraries for creating static, animated, and a very interactive visualization in Python. It provides a very comprehensive set of tools for constructing a wide range of plots as well as charts. So Matplotlib is highly versatile and it supports various different plot types, including line plots, scattered plots, bar plots, and histograms. And there are many more. So you as a user can have a very fine-grained control over the plot elements as well as the appearances. Also, Matplotlib allows users to create publication quality plots that are suitable for academic publications, presentations, and even reporting. So, Matplotlib has features like customizations of labels, titles, legends, and even annotations. So, with Matplotlib, users can actually visualize basic data relationship. They can explore current trends and even identify any pattern in your data sets. It is basically well suited for both exploratory data analysis and even the final polished visualization. Also, we will be looking at the link for the Matplotlib documentation. Next up, we have Seaborn. So Seaborn is a statistical data visualization library in Python, which is built on top of Matplotlib. Okay, it provides a high level of interface for creating interactive and even informative statistical graphics. Also, Seaborn, specializes in creating statistical visualization like scatter plots, box plots, violin plots, and even pair plots. So it basically simplifies the process of creating complex, statistical plots. And Seaborn comes with aesthetical, pleasing default themes, color palettes that enhances the visual appeal of plots. So users can easily customize the themes and colors according to their own preference. And this is also, I will be sharing with you all the links of the documentation of all of these different statistical data visualization libraries. And next up here, we have Plotly. So everyone, Plotly is a library for creating interactive and web-based visualization. So it is particularly well suited for building interactive dashboards and applications. And Plotly enables users to create a very interactive plot, with features like tooltips, zooming, panning, and even a clickable element. So it is suitable for scenarios where user interaction is very crucial. Also, due to its interactivity and support for web development, Plotly is often used, for creating dashboards and interactive reports. Also, Plotly facilitates seamless data exploration of data through interactive visualizations, helping users uncover insights in real time. So everyone, these libraries that we just saw, all these three libraries cater to very different needs as well as preferences, right? So, and all of them are, they cater to different needs and preferences, but in the same ecosystem, which is data visualization. And the choice between all of these different libraries depends on the specific requirement of your project. So Matplotlib basically provides a very solid foundation. Seaborn simplifies your statistical visualization, and Plotly excels in interactive as well as web-based scenarios. Next up, we have the Matplotlib Matplotlib module basics. Okay, so let's look at Matplotlib's Python plot. So Matplotlib PyPlot module is the fundamental part of Matplotlib library, which serves as the core for constructing various type of plots. Also, it provides a very high level interface for creating basic plots very quickly. And PyPlot simplifies, the process of creating different types of plots, such as the scattered plots, bar plots, histogram. So users can generate plots with just a very few line of code, making it accessible for both beginners and experienced developers. And the PyPlot module, it provides a unified interface for constructing plots, allowing users to simplify plot elements, customize visual styles, and even add annotations. Also, it has a very straightforward interface and a very, versatile plotting. So what this means is that uh, PyPlot is designed to have a very straightforward and a very easy to understand interface. So users can basically quickly grasp the basics of creating plots without dwelling into the complex configuration. And while being simple, PyPlot is highly versatile and flexible. So users can customize, virtually every aspect of their plot, including access, labels, titles, colors, etc. And it even accommodates users with various levels of expertise and diverse visualization requirements. And statistic visualization constructor means that PyPlot primarily focuses on construction of the statistic visualization which are non-interactive and suitable for presentation reports and even academic publication. So it lays the foundation for more complex and insightful plots that can be used for data exploration and communication. And lastly, users have a granular control over plot elements, allowing them to fine tune the experience of the plot and communicate data insights effectively. And lastly, static visualizations created with PyPlot can easily be shared as well as they can be reproduced. Now, everyone, this is how the so everyone, this is the data visualization, which is Matplotlib documentation. So what you all can do is you all can navigate to this and go through the website and go through the overview that is provided here, the plot types that are given, the statistical distributions, etc. So I am going to be sharing these links later on in the chat box section. All you have to do is just type matplotlib.org and it will navigate you to this page. Next up, we have Seaborn for statistical visualization. So, Seaborn is specifically crafted for statistical data visualization, which offers a very high-level interface compared to our Matplotlib. So, it aims to simplify the creation of statistical plots commonly used in data analysis. And Seaborn even provides tools for generating visually appealing statistical graphics that convey complex information in a clear and concise manner. It also includes specialized functions for common statistical plots like scatter plots, box plots, Boolean plots, pair plots, etc. Now, the advantage of Seaborn over Matplotlib is that it helps in building on Matplot's foundation. Basically, as we know that Seaborn builds on the foundation of Matplotlib, leveraging all of its core, functionalities. So while Matplotlib is very versatile, Seaborn extends it with, extended capabilities which are specifically tailored for the statistical visualization. And enhanced capabilities means that Seaborn introduces additional features and functions that streamline the creation of statistical plots. This includes specialized functions for handling categorical data, automatic estimation, and even plotting of confidence interval, and even built-in color palette which are optimized for our statistical plots. Lastly, easy to use. So, Seaborn is designed with a very user-friendly interface, which makes it more intuitive and acceptable for users, especially those new to data visualization. Next up here, we have an image of the documentation of Seaborn. So you all can just navigate to seaborn.pydata.org to look into the documentation of Seaborn library. Next up, we have Plotly. So everyone, starting off with Plotly. So Plotly is renowned for its highly interactive capability. Okay, and it's actually Plotly is set apart from the statistic plotting libraries like Matplotlib as well as Seaborn because it allows users to interact with charts dynamically, and it also provides a very engaging and even a very responsive experience. So Plotly charts can be updated dynamically in response to user interactions such as hovering over the data points, clicking, zooming, dragging, etc. So this dynamic behavior facilitates real-time exploration and analysis of your data. And users can interactively explore the data points with Plotly charts, gain a very deep understanding of the underlying patterns and trends. And lastly, Plotly supports features like hovering and tooltips and also provides additional information about the data points where the user hovers the cursor over them. And this enhances the exploratory nature of data analysis and visualization. And lastly, about enhanced engagement, users can actively participate in exploring and interpreting the data, which leads to a much more intuitive and an immersive, experience. And Plotly is well suited for creating interactive dashboards, where multiple charts and visualization can be linked together, offering comprehensive view of the data, and users can interact with one chart and the other dynamically respond, and they also provide a very cohesive and an interactive dashboard environment. So everyone, this is also the documentation of Plotly. So please navigate to plotly.com. Next up, we have plotting univariant distribution. So everyone, about univariant distribution. So univariant distribution basically refers to the statistical distribution of a single variable with a data set. Basically, it involves analyzing the spread and pattern of values for that specific variable. Now, the importance of understanding this individual variable is you need to identify the central tendencies. Basically, you need to examine the univariant distribution because it helps in understanding where most value clutters, okay, indicating the central tendency of variable so that you can measure the mean, you can measure median and mode, and it can be derived to pinpoint the center of distribution. You can also Next up, we have access, spread, and dispersion. Basically, univariant distribution allows an analyst to observe the range of values that the variable takes. Basically, where it measures, the range, the variance, standard deviation, and it also provides insights into the how spread the values are from the central tendency. And detecting outliners. So outliners are which are extreme points in your data set, okay, and they can actually significantly impact the analysis. So univariant distribution plots such as a box plot or histogram, they make it easier to identify outliners that may actually skew the analysis or even identify the anomalies in the data. And lastly, inform subsequent analysis. So basically, when you are going to understand the univariant distribution, it serves as the foundation step for many advanced statistical analysis and modeling, which subsequent analysis such as bivariant or multivariant analysis often builds upon the insight gained from the univariant distribution. And the methods for plotting unvariant distribution are histogram. There is KDE, which is kernel density estimation. We have box plot, we have Weiland plot, and we have a probability plot. So everyone, we are going to go through all of these plots when I'm going to take you all through, codes. And here you need to and so we need to basically understand univariate distribution because it is like the fundamental step in exploratory data analysis, and it also offers insight into the characteristic of an individual variable, which helps analysts make very informed decision, detect patterns, and even perform actually prepare the groundwork for more advanced statistical analysis. Next up, matplot basic univariant plots. So, as I already mentioned about histogram and box plots, we're just going to go in depth of this. So, everyone, a histogram is a graphical representation that displays the distribution of a data. It is constructed by dividing the entire range of values into a series of intervals. These intervals are also called as bins, and counting how many values fall inside each bin. Now, there are a few important things in a histogram. Okay, so you need histogram, so you need to take care, or you need to understand the central tendency and spread. So because they are useful for understanding, okay, central tendency and the spread of the data set. And even histogram, it has a bin constructor. So the data set range is divided into bins, and the height of each bar in the histogram corresponds to the frequency of values within that bin. And the shape of the histogram can also provide insights into the underlying data distribution, such as whether it is symmetric, skewed, or has multiple peaks. We also have box plot. So box plot, a box plot is also known as a blocks and a whisker plot. Okay, it is a method for graphically depicting groups of numerical data through its quartiles. So it actually provides a summary of the data's, central tendency, dispersion, and skewness. So there are a few key points that you need to keep in mind about box plot. It is that box plot, they actually provide a visual summary of distributions, central tendencies, spread, and potential outliners within the data. And quartiles representation. So the box in the plot represent interquartile range, IQR, between the first quartile and the third quartile, with a line inside indicating the median. And whiskers and outliners, whiskers actually extend from the box to, from minimum to maximum values within the range. And points beyond the whisker may be considered outliners. And lastly, box plots are very useful for comparing the distribution of different categories of group, making them valuable for exploratory data. Next up, we have a program here. Just give me one moment, everyone. All right, so now everyone, I hope all of you all are able to see my screen. Here, what we are going to do is we are going to go through this code here. Okay, so firstly, in this first code, what we're going to do is we are going to import a few libraries, and then after that we are going to use a data. So everyone, instead of going through the programs now, what I am going to do is I'm going to explain all of the programs at the end. I have a few files too in the Jupyter notebook. I will launch and we will go through these examples. So next up here, we have Seaborn plot. So firstly, Seaborn's plot is a specialized function for creating univariant distribution plots. So it provides a high-level interface for visualizing the distribution of a data set, which offers flexibility and even which is easy to use. So here what we are going to do is just, there are a few parameters here that are given. Okay, let's just go through them. So data is basically the input data. Typically, it's going to be one-dimensional, or it is going to be any pandas series. Next, we have bins. So bins are a specification in your histogram, and it determines the number of intervals are the bin in your histogram. Okay, it is going to basically indicate how many bins are going to be there in your histogram. There is KDE. So KDE is a Boolean parameter indicating whether to include the kernel density estimation in the plot. So you can either keep it true or false using the Boolean values. And lastly, we have a rug, which is a Boolean parameter indicating whether to include a rug plot which displays individual data points along the distribution axis. So data, so everyone, the data visualization, okay, so displot, what displot does, it allows for the effective visualization of the univariate distribution of a data set, and the bin parameter, it specifies the number of intervals or the bin in your histogram, all right, and the KDE, which is kernel distribution estimation, whenever it is true, it indicates that KDE in the plot, and it provides a very smooth representation of your distribution. And lastly, about a rug plot is included, which displays individual data points along your distribution axis, and also it enhances the granularity of your plot. Next up, we have another code here, everyone, which we will be looking at in part 2 of this video. Next, we have introduction to bivariant distribution. So bivariant distribution is a statistical concept that focuses on joint distribution of two variable in a data set. So it basically aims in understanding the relationship, association, or even the dependencies between two variables by analyzing how their values co-vary or change together. So the key concepts here is joint distribution, scattered plots, correlation, and covariance. So firstly, joint distribution. Joint distribution represents the probability distribution of two variables considered together. Scatter plots are a graphical representation that displays individual data points in two-dimensional spaces, allowing for visualization of a relationship between two variables. And correlation measures the strength and the direction of a linear relationship between two variables, and ranges are from -1 to 1. And covariance measures how much two variables change together. And this positive covariance indicates a positive relationship, and negative variance, it basically highlights or indicates a negative relationship. And lastly, joint probability distribution. Joint probability distribution is it basically calculates the probability of simultaneous events or even values for two variables. Now, to understand the importance of data analysis, it helps you understand relationships. Okay, bivariant distribution helps analysts understand how variables interact or even influence each other, and how they perform. The pattern recognition is basically analyzing the bivariant distribution, which aids in recognizing patterns, trends, and even clusters in your data. And bivariant analysis provides insights into the potential relationships that can be used in a very predictive model. And lastly, knowledge of joint distribution helps in making informed decisions based on interdependencies of variable. Next up, we have Matplotlib and Seaborn for bivariant distribution. So here we have scattered plots, we have joint plots with Seaborn, and pair plots for multiple variable. So let's go through them. Okay, so firstly, a scattered plot is a two-dimensional plot that displays individual data points on a Cartesian plane with one variable on each axis. So the key points of scattered plots is that scattered plots visualizes the relationship between two continuous variables. And it is very useful to identify patterns, trends, and even potential outliers. And then we have joint plots with Seaborn. So Seaborn joint plot provides a comprehensive visualization of the bivariant distribution by combining a scattered plot with the histogram for each variable. And the joint plot provides a very quick overview of the relationship between two variables, including marginal distribution and options for, the kind parameters such as scatter, KDE, and hist. And lastly, we have pair plots for multiple variables. So Seaborn pair plots, they create a matrix of scattered plots for multiple variables, allowing for a quick examination of pairwise relationship. And the the pair plot is basically suitable for exploring, relationship between multiple variables. So just to you know highlight a few advantages of scatter plot is that scatter plot offers a visualization representation of two variables. Okay, it identifies outliners, it has correlation assessment, and even it enhances your understanding. Next up, this is another example that we're going to cover in part two. Yes. So everyone, next up we have Python visualization, categorical plotting. So first we will start with strip plot, then swarm plot, and then later we will look at box plot. So firstly, strip plot with Seaborn. So a strip plot is a type of a scatter plot where one variable is categorical, and it is basically useful for visualizing the distribution of values within different categories. They have parameters like x, y, hue. It has data. It has jitter. So x, y, hue are names of variable. Okay, in the data of vector data. Data is the data frame, array, or even a list of arrays, the data set for plotting that can be used. And jitter is, again, it is a Boolean value. So jitter is useful when there are many points and you want to avoid overlapping in your plot. Next up, we have the swarm plot. So swarm plot is a type of categorical scatter plot similar to a strip plot. So the primary distinction is that swarm plot adjusts points to overlap, to prevent overlap, which is providing a very clear representation of your data distribution. And then, as you can see here, to use them, you have to import Seaborn, okay, as an alias, and then use the function SNS. So use the function swarm plot along with the name of the library, which is SNS in all of these cases. And lastly, we have box plot with Seaborn. So uh, here, everyone, box plot, so a box plot is a visual representation of distribution of your numerical data through quartiles. So it is a very valuable tool for detecting outliners in your data. And here we again have x, y, hue, and data, which are the common parameters. Next, we have the bar plot. Okay, we have bar plot, count plot, and point plot. So bar plot is used to aggregate categorical data according to some method, with the default being mean. And then we have count plot. So count plot is used to display the count of observation in each categorical bin using the bar. And lastly, we have point plot. So point plot is used to show point estimates and even confidence intervals using a scatter plot graph. And again, here we have X, Y, and hue. And lastly, we have cat plot with Seaborn. So cat plot with Seaborn is cat plot with Seaborn is a very figure level interface, okay, for drawing various types of categorical plots on the face grid. So the kind parameters used to specify different types of categorical plots, such as strip plots, swarm plots, box plots, violin plots, etc. And it has pattern parameters like x, y, hue. It has data, row, and columns, which are names of the variables in the data, and it is optional. There is kind, which is string, or you can again, that is also optional. You can have you can have box, violin, point, bar, count, etc. Also, everyone, I request all of you all to go through the documentation that is provided here. The links are already provided, so please go through them. Now, everyone, in part two, we are going to be looking at the categorical plotting demos, basically the data visualization modules, demos. So that is it for this module. Let's meet in the next part and cover all the different topics that we have just looked at. Thank you, everyone.